Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on finding information from a computer printout. So, scenario is too cold to move. A random sample of 12 babies and the temperature they began to crawl was taken. Is there association between temperature and crawling age? All right, so we're looking for temperature and crawling age. And we always start by finding the most important word, which the starting word is constant. All right, so once we find the word constant, we know we have the y-intercept row. So there's our y-intercept row, and the row below it is our slope row. Well, the very first thing it asks for us is our explanatory variable, which is basically our x. So that means average temperature. So let's take a moment and go back up and look at this. A random sample of 12 babies and the temperature they began to crawl. Well, we know temperature, we just said temperature was the X. And they wanted to know whether there's association between temperature, which again is our X, and crawling age. And crawling age happens to be our Y, or response. Okay, so the very first next thing they asked for after our explanatory variable, which we said was average temperature, is the y-intercept. Well, the y-intercept is going to be on the y-intercept row, of course, and it happens to be the first number, which is 35.678. The next thing we're going to ask for is slope, and not surprisingly, it's going to be the slope row. And in this case, we have a negative slope, and it's going to be negative 0.07774. And then it asks for our standard error of the slope. So we need to be on the slope row. We have two standard errors, but we need to be on the slope row. So in this case, it's going to be 0.0251. I guess I should highlight the word slope. The next thing he'd ask for is our regression equation, which in this case, we know our response variable is crawling age. And I'm just going to put age to make it shorter. Age, and I'm going to put a hat on it, equals my y-intercept, 35.67806, minus, and I'm going to shorten this up to 0.077, and average temp. So I could have just put temperature. So here's my X, and here is my Y. Now, once again, I could have written this as, but I'd have to define my variables. I could have written this as Y hat equals 35.67806 minus 0.077x. All right, so we could have written it like that. The next thing it asks for is a t-statistic for slope. Matter of fact, we see slope here twice, so I'm going to go ahead and highlight them right now. So t-statistic for the slope. So we're going to need to be on the slope row, and there's the t, so it's going to be negative 3.0971. The next it asks for is the p-value for the slope. Once again, I'm going to have to be on the slope row, which is 0.0113. Then it asks for our coefficient of determination, which really doesn't show up there as that, but we know that that is our r squared. And we look and we have two r squareds. but we'll never use the one that says adjusted. We're just going to use this one. So I'm going to label this CD for coefficient of determination, and that is our letter H, and our value is 48.96%. And I'm going to go ahead and leave it as a percent right there. Then it asks for our correlation coefficient. Well, our correlation coefficient doesn't show up directly on this, but we know that our correlation coefficient is going to be the square root of r squared. So I need to take that r squared and I'm going to divide it by 100, 48.96 over 100, because we always divide percents by 100 to get them to a decimal. So 48.96 divided by 100. And I like to raise it to the half power. And we end up getting 0.6997. So our correlation coefficient is 0.6997. But we need to hold on a moment. The correlation coefficient has two components. The first component, sine of the slope. So we need the sine of the slope and we need the square root of r squared. So sine of the slope and r squared, we just did the r squared part. We need to take a look at the sine of the slope. In this case, our slope is negative, so our coefficient of determination will also be negative. The last thing it asks for is the standard deviation of the residuals, which is just our big S. And our big S is 1.3192. And that's our standard deviation of the residuals. Well, I hope this helped a lot, and I look forward to seeing you on the next one. Thank you.